Hi everyone and welcome back. Now in today's video we are going to discuss about one of the relatively new feature in Terraform, which is the check blocks. So let us go ahead and understand the basics on what check blocks allows us to do. At an overview, a check block, it can validate the infrastructure that is outside the usual resource lifecycle. Now, when we discuss about various other conditions like the input variable validation or a precondition, post-condition, these generally reside within a specific resource block. However, when we discuss about check blocks, they are not directly under the resource block and they can go ahead and evaluate the infrastructure that is external as well as internal to the Terraform configuration. For example, let's assume that you have your folder here and inside the folder you have ec2.tf and check.tf. So ec2.tf, it will go ahead and launch a ec2 instance. This is simple. Check.tf, again, depending upon what code that you have written, let's assume that it is going ahead and it is checking for a specific website, whether the website is running or not. So these are two independent functions that the ec2.tf and check.tf are doing. Now, if the website is not running, many times what happens is that the EC2 instance has a dependency on a website to fetch some details or maybe update some details and so on. So in such case, when dependency is there, you can go ahead and depending upon what you would want to achieve, there are multiple set of custom conditions that you can make use of in order to verify. Now the question that comes is, what exactly is the use of this check block? We understand that it can go ahead and check if a specific resource is running or not running. But how will it help me as part of the infrastructure? Let's go ahead and understand this step by step. Now, generally, many organizations, they make use of the data source block plus the instance block. For example, let's say that this specific resource over here, again, this is a local file just for an example. Let's assume that this is a EC2 instance. So this EC2 instance, it depends on a specific website. So if a website is not running, then the application in the EC2 instance has no use. So what organization they will do, they will add a data HTTP block to verify if a website is running or not. If the website is not running, then immediately the Terraform apply will fail or the Terraform plan itself will fail, and the resources that are part of the code, be it EC2 instance, be it any other resource that might not have to do with the website, everything will fail. So for example, when you do a Terraform plan here and considering that the website fails under this specific data source, immediately you get an error. Now, even if a resource is not dependent on the website, we know the EC2 instance might be dependent on this website, but a local file might not be dependent on the website. So irrespective of that, everything will fail. So this is one of the behaviors. Let's also go ahead and observe this. Now for today's practical, I have a file called as check-block.tf. It has a simple data source over here. What this data source is doing, it is checking for this website, google.com. And I have a resource of local file. What it is doing, it is creating a local file of foo.txt and that's about it. Now at this stage, there are no dependency between each one of them. Now from the CLI, if we do a Terraform plan, at this stage, you see, our local file resource is being planned to be created. It is showing one to add. So this is as expected. However, this is happening only and only after this specific data block here, which is checking whether google.com is working or not. So suppose, let's say I add some random URL here, which we know that it does not exist. I'll save this. Now I do a Terraform plan once again. Now you see, immediately it gave an error. So this is our Terraform plan. It showed us this plan. It showed us one to add, but immediately error making request, no such host, and this is the URL. Now let's try to do a Terraform apply with auto approve. Let's see if it creates a local file or not. So at this stage, our kplabs Terraform folder does not have the foo.txt, which is added as part of this local file. So ideally, if this resource runs, then foo.txt should be created in the same folder. Now, if I do a Terraform apply with auto approve, you see it shows one to add, but the apply never completed. It got stuck at this part. So if I refresh this, let me show you. If I refresh this, our file never got created. So this is like a default behavior when you use the data source block. If it fails, then the other resources, even if they are not dependent on it, they will fail. Now again, it depends upon the data source that you use. Not all data source has this behavior. HTTP does have this behavior. There are alternatives, but we are just discussing about the default configuration here. Now, when we discuss about the overall check block, it looks something similar to this. So all you have to do is you have to define check followed by the name, and inside the check block, you can have nested data source block. So the exact data source block that we had used, instead of directly specifying it, you can add it inside the check block here. Alright, so this is what is referred to as nested. Now, one of the big benefits here is that if a scoped data source provider raises any error, they are masked as warning and do not prevent Terraform from continuing operation execution. So what that would mean is that if this website does not exist or if this website fails, then it will not block your Terraform execution. It will show you the warning stating that, hey, this website is not working. However, the resource creation or any other changes will not be blocked. Only a warning will be given, but your Terraform will work perfectly well. Alright, so I hope with this you understood what check block is trying to do here. Now before we go ahead and look into the practical aspect, let's go ahead and also explore the format of the check block. Now we were discussing that inside the check block you can have the nested data source block. However, this is not the only thing. So the check block must have one assert block. So this is one minimum. So if you see, this is the assert block, and inside the assert block you have the condition and you have the error message. So if you have studied about the input variable validation or precondition, post-condition, all of them also have the condition and error message. However, the name of this block changes. So in precondition, you have precondition, then you have post-condition. However, in check, you have the assert block over here. The aim of condition and error message remains to be the same here. So this is one important part to remember. So one minimum assert block must be present, and each assert block must have a condition attribute and an error message attribute. So within here, you can add whatever condition you'd like. So let's go ahead and try this out. So now what we are going to do, this specific data source that we had, let's go ahead and add a check block here. I'll say website checker. And inside this, let's have a closing here. Inside this, we have the data source block. Let's format it correctly. And as we know, in the check block also, there must be assert. So I'll say assert. And inside the assert, we need to have condition and error message. So in the condition, what is going to be our condition? Our condition is going to be whether this data block succeeds or it fails. So what you can do, I can say data.http.example. Now within here, you can just explore the HTTP data source and you can look into the attribute which one gives the appropriate status code. So the status code here is as part of status underscore code. So you can say dot status underscore code is equal to 200. All right. So if the website is working perfectly well, then the condition succeeds and everything is happy. However, if this specific fails, then you can say website is not running, please check. All right. Now, one point to remember is that even if this does not succeed, that is completely fine. Check block is not going to halt your execution. So let's go ahead and clear the screen. This time we'll do a Terraform plan here. This time you see, we got a warning message which states no such host. This is completely fine. We'll clear the screen. We'll do a Terraform apply with auto approve. Let's see if our resource gets created or not. And as expected, our resource is created. We got a warning message stating that no such host, but the resource execution continued to happen. Alright, so I hope with this you understood the basic of check blocks. Now let us also understand some of the use cases where this check block can be useful. The first sample use case is related to the AWS budget. So if you see, you have check budget exceeded and it is using a data source block of AWS budget. So it can go ahead and check the overall budget of your AWS. Let's say that your budget is $1,000, but now it is going beyond that. Then using the check block, it can alert you. You see, AWS budget has been exceeded, calculated spend is $1,550 and the budget limit is $1,200. So this again is a very important use case that organization can make use of. Now again note that it can happen that the check block has nothing to do with the resource that you are creating. You are using check block to go ahead and get an alert on wide variety of use cases like AWS budget or website is running or not and so on. Alright, so it is not always to do with the resources that you are creating. You can have a separate check block that run continuously, let's say every 1 hour, every 2 hour in your environment in an automated fashion, and whenever check block detects something, you can get an alert. So this is one of the ways in which check blocks can prove to be useful. So this is what the next point is all about, which states that the check block becomes useful when they are regularly run in an automated environment, and it can also alert us if they fail. So if a budget exceeded or if a website is not running, then you should get an alert over email or over Slack, etc. This is where the check block proves to be useful. Now, whenever you are making use of the HCP Terraform, which is the HashiCorp cloud platform, in such case, check blocks can be used as part of the continuous validation feature. So the HCP Terraform here, it can continuously check for wide variety of use cases like your budget, your overall website is running or not. It gives you a nice little dashboard here. And if say website is not running or budget has exceeded, you can see it from the console, but more important, you can also get notification over email and so on. So this is where check block proves to be quite important here. Now before we conclude, few pointers that you have to keep a note of. First one is that as we were discussing the assertions that we add as part of the check block, the assertion do not affect the Terraform execution. All you'll get is a warning and that's about it. Now, when you compare it with pre-condition and post-condition, generally if a pre-condition fails or post-condition fails, you will immediately get an error. However, in terms of check block, this is not the overall use case, and this is the reason why check block can prove to be useful for wide variety of use cases here. Now I also wanted to show you one of the Terraform blog here which states 8 Terraform continuous validation use cases for AWS, GCP and Azure. So within here, if you notice, one of the use cases here is related to the budget. So this is the overall assert block, condition and error message. Now again, from exam perspective and all, you don't have to write custom error message that are complex and all. You just have to understand things at a basic level here. However, for organization or for enterprises, whenever you're implementing things, you should know what flexibility the check block allows us to provide. All right. So this is one of the examples. I'll also be adding the link here in case if you'd like, you can also use the same code. But again, as we're discussing, just adding it as part of your code does not really prove to be useful. You need the check block to run continuously. You need it to alert us via email or something. So in case if you're using some kind of a platform like HCP Terraform, then this proves to be very useful. So this AWS budget is something that we were discussing. Then you also have something like detecting threats. So here you have the guard duty. So it will check whether guard duty has detected any threats as part of the environment. If it has detected threats, it will go ahead and alert us. So here you see it states guard duty has detected 9 open findings. Then again for Google Cloud, it states assert that VM is in a running state. Again, this is a useful feature. You want to check if your critical servers are in running state, if your database server is in running state continuously. So this is where again the check block can be useful. Again, the next use case is if a certificate will expire within a certain time frame. This is very important. I remember in one of the organization where I was working with, I newly joined in that organization. Now I even did not have access to the Nginx server and all. and only after a few days the certificate expired and entire website, entire mobile application, everything went down. So generally what happens is that if you are using Android or iOS, the application has to verify if the certificate of website is valid. If it is not valid, then you will have lot of issues, specifically from the mobile application side. So this is one critical part which lot of organization they generally forget. So having a check of this is very important. And again, this is not related to just Google Cloud. Even for AWS also, you can verify the certificate expiry date. And again, there are other use cases that you can look into. Again, I'll be adding the link after this video so that you can explore this. So that's a very high level overview on what check blocks allows us to do in Terraform, and with this we'll conclude today's video.